Hello, it's Tropical Troop here today. The great, amazing Tropical Troop. Okay, so it's Tropical Troop here today, and today we'll be trying to do the 100 Integrals by Black Pen Red Pen on YouTube. I don't have anything better to do, so this is what I'm gonna be doing. I'm probably not going to be able to finish all 100 today, considering the last calculus I touched was 2 months ago. Well, 1.5 months ago. And yeah, I basically forgot everything. Like, low-key, what is an integral? So, I'm going to have a lot of fun with this. There's going to be a lot of referencing the thingamajig of integrals, unless I want to derive all of them by hand. Integrate all of them by hand. So excited. Okay, so the amount of time I've spent should be basically the same as how long the stream is. And we'll basically just start, cause yeah, here. So we'll just write okay, let's get started. Okay, so the first problem, let's write this, let's just keep swatches here. Okay, question number 1. I like green. Question 1. The integral of tangent 5 secant cubed x dx. My. So we know that the derivative of tangent d dx, okay, d dx tangent what is the derivative of tangent? Secant squared x, right? So, okay, let's go back to black. So we know that this holds true. That means and we know that the derivative d dx of secant x equals this derivative of secant equals tan secant x, right? So if we say u and tan x is just equal to sine over cosine. So that means tan 5x equals sine 5x over cosine 5x. Since secant equals 1 over cosine x, that means secant cubed x equals 1 over cosine. Okay. Now, what can we do with this knowledge? That's a great question. And I have zero clue. Let's see. Now, let's substitute u for tan. So u equals tan 5x and du equals 5 tan so that means we get du over 5 equals tangent 4x times secant squared x dx. This is just okay. So that means this becomes interesting. Okay, wait. I think I got it. If we set u equal to secant squared x, that means du equals 2 secant x times sec x tan x dx. No, but that gives us another secant squared x. Okay, let's just erase all that. Oh god. Now let's try it. I'm so confused. This is the first problem. Okay. We got this. If we make what if we integrate by parts? We say u, no, but then we'd need the integral of tangent, and the integral of tangent is a mess. Hey, wouldn't this just be... Wouldn't this be tan? Wouldn't this be equal to integral of tan squared x times tangent secant cubed and if we make u equal to what if we make du equal tan x so then the integral of this would equal I have no idea what I did here, but okay, so we need to figure out some way to make du equals secant tangent x. Wait. If u equals tangent squared x, du equals 2 tan x times secant squared x. No, but the problem is we're left with a tan squared x and a secant x. Wait, we're left with the... Wait. Okay, wait, we just go back to tan. we make this equal this doesn't work. What if we would just make u equal to tangent x? Right? Du equals secant. See, this is the problem we are getting. How long have I spent on this problem? Oh, I didn't start the timer. Okay, we got this. We will not give up. Okay, let's look at this with fresh eyes, you know? Okay. Now, this would become sine this would become sine to the 5th over cosine to the 8th. So it would be the integral of this. Now, if we multiply top and bottom by 5, that wouldn't do anything. Wait. Huh. The problem is there's a secant that's always going to be left behind. Right? Because we get secant squared x. Did I read this right? Yeah, I did. Now if we just plug this back in, we get this is what we end up with. Now, the problem with this is that I don't know what the hell to do. Yo, I'm trying to do the 100 integrals. It is not working. Okay, that's... Okay, let's see. 1/2 u squared secant x. Let's see. Okay. This should not be this much of a struggle. I swear I've done this like 1,000,000 times before. Wait. If u equals secant squared x, no, if u equals secant x, okay, u equals secant squared x, that means du equals 2 secant x times secant x tan x. Oh, no. Okay. Right? Secant x. Then du equals secant. Oh, says. Oh, whoa. Du equals secant x tan x. Right? So now we get dx. That means we get tan 4x times u squared dx du. Now what do we do with this tan 4x? Technically this is just sine times u to the 4th u squared, because this would just, this is right? So then, since cosine, this thingamajig is just secant to the 4x. Oh! Wait. Wait. So then that just becomes u to the 4th. So then we get sine 4x times u to the 6th du. Huh. Nope. Why are these integrals so hard? Okay. What if so then that becomes one over cosine x would be the same as tangent divided by sine. And we know that tan equals u. So then that becomes 1/2 integral of u cubed divided by sine x du. Interesting. I will not give up. What if we did tangent to the power of 4? No. We needed to somehow, we want some d dx to equal secant cubed x. This could be secant squared x times secant x tan x. Right? So then that would get rid of both secant cubed and 1 tangent. But the only thing that makes this would be the derivative of secant. See, the problem with this is that we're left with a tangent to the power of. Should I just try integrating by parts at this point? Yep, that seems like the plan. Okay. U equals tangent 5x. du equals phi tan 4x times secant squared x. dv equals secant cubed x dx. V equals integral of secant cubed x dx. What? You know what? This is all going to go bye-bye again. Okay, so now this would be much more fun to do. 5 tangent 4x times secant cubed x plus tangent to the 6x secant x, and v equals a nice tan u. Isn't that nice? Tan x, right? V equals nice tan x. Great. Now, uv, so tangent 6x secant x minus integral of that's not very fun, is it? Okay, well, we'll be moving on to the next integral. Question 2, because we couldn't solve question 1. Okay, so double angle is a very fun formula. This becomes cosine squared x minus sine squared x. This would be a squared minus b squared. So a squared minus b squared. Now what does a squared minus b squared equal? A minus b times a plus b. Right? Because then that becomes a squared plus ab minus ba minus b squared. These cancel out. Oh, I should be in a different color. These cancel out, and you get a squared minus b squared. That means this applies. So you get a very nice cosine minus sine times cosine plus sine. This is the same as that. They cancel out. So you get cosine minus cosine x minus sine x times cosine x plus sine x over sine x plus cosine x, and that nicely cancels out. And we are left with a happy cosine x minus sine x dx. this is just equal to sine x plus cosine x plus c. Now I have no idea if this is correct, which is why we will now look at the answer. Okay, we are correct. Let's go. Okay, this is correct. Let's go. Next question. X squared plus 1 over x to the 4 minus x squared plus 1. Okay. So, once again, there are certain formulas in the world of mathematics, like x squared minus x times x squared plus x. I have no idea if this works. No, it's just x squared minus 1 times x squared plus 1. Right? No, I think it's this. Here, wait. This should be an integral. Okay, cool. Now, if we take out the x squared, we get x squared minus 1 plus 1. Yes. I want to try doing partial fractions on this. Okay, cool. I want to try partial fractions, but I don't know if it'll work. Here, let's try going back to the first problem. Let's just... Now, u equals tangent secant du equals product. No, we don't want product rule here. Yeah, we don't want product rule. Okay. This is equal to sine 5x times secant 8x dx, right? Okay. Okay. So it has been pointed out to me that I can actually use a Pythagorean identity here. That is tan 5x I have no idea how to do this for some reason. Yeah, we're not doing limits. Integrals are much worse. Okay, so we're actually going to be calling a friend now. It's phone a friend time. Hello.
Hello.
You're on stream.
Okay.
Okay.
Do you know how to do it?
I'm trying to figure it out. I could figure out the next one, but not this one.
Okay, so you know what the derivative of secant x is.
Right, yes. Secant tan x.
Okay. So you have to think about how you can make a secant tangent x. So basically what you do is you pull out a secant x from tangent x to the power 5 and secant. Just pull a tangent x secant x out. And then after that,
Okay,
you just use
so
the identities and solve tangent in terms of secant. So it turns into the square root of secant squared x minus 1. And then that just turns it in, and since it's to the power of 4, it just becomes squared. And you solve down from there.
Okay, wait.
I think you substitute secant x. Yeah. And this becomes u squared minus 1 in parentheses times u squared.
Okay, I have no clue. I am confused.
Okay. Get on Discord, I'll whiteboard it to you.
Okay. One second. Okay. Hello.
Hello.
Hi. So.
Are you on it?
How do I join it? Oh, I see it.
Okay. So, we have tangent squared x plus 1 is equal to secant squared x, right?
The thing isn't loading for me.
Just scroll out, zoom out, scroll out.
It's not letting me zoom out.
It's not letting you zoom out.
Oh, okay, yeah, I see it now.
Yeah. And now let's just turn into tangent 4x secant squared x times tangent
tangent x, secant x, right?
Yeah.
And this is basically the derivative
Of
of
secant.
x.
Yeah.
So now what you're trying to do is turn this term in terms of just secant x. So you can just u sub it in and then cancel this term out. And how do you do that? You solve this in terms of secant squared x, in terms of tangent, and then you plug it in.
Wouldn't that just be tangent
Well,
equals?
no, solve in terms of secant, and then you plug in for tangent. So that just turns into...
Would it not be that?
Root. Yeah, it is that.
Oh, okay.
Now you plug it in for tangent x, and you get secant squared x minus 1 squared, because it's to the power of 4 and it's the square root.
Oh.
Secant squared x, and then now you just u sub for secant, and then this term cancels out, and you get u squared
minus 1 squared. I see.
And you could solve this from there.
Okay. Let's see. Let's go back to the whiteboard. Main whiteboard. Okay. So, to anyone who didn't understand, not that anyone's even watching the stream. Basically, tangent squared theta plus 1 equals secant squared theta. And this is a Pythagorean identity. Now, if we isolate the tangent theta, we get tan theta equals square root of secant squared theta minus 1. Great. We then plug this into there. Then we get square root of secant squared theta minus 1 whole squared times secant squared x times secant x tan x dx. This becomes the integral of secant. Oh, this is to the fourth.
Remove the square
root. Yeah. Secant squared theta minus 1 to the second times secant squared x times secant x tangent x dx. Then you substitute u into secant x. So then that becomes the integral of u squared. Why are there thetas some places and secants on the others? Okay. U squared minus 1 whole squared times u squared and we know that du equals secant x tangent x dx. So then we just replace this. This becomes du. So then that's du. Now you can do the fun magic. And since I'm lazy, I'm just gonna expand this out. So you get u to the fourth minus 2u squared minus plus 1 times u squared d.
I forgot to do that at the last part.
And then that becomes u to the sixth minus 2u to the fourth plus u squared du. Now, I have no idea how to take the integral of this.
Are you joking?
I'm kidding. 1/7
Okay.
u to the 7th minus 2 over 5 u to the 5th plus 1/2 u to the... Oh, okay, I'm slow. Plus c. Now we plug it all back in and we get secant x, secant 7x over 7 minus 2 secant to the 5x over 5 plus secant cubed x over 3 plus c.
I shall go now. Goodbye.
Okay, bye. Oh, hi, DJ Ross. I didn't see that earlier. Okay. I've spent 55 minutes on this stream and I've solved 2 problems. This is actually like great. Now, there has to be a trig identity for, an identity for this. I'm gonna say it's x squared plus 1 times x squared minus, oh. Did I get this right? Yeah, I did. Okay. Oh, okay. So then this would be right? So now you're left with okay, there has to be a way to do this. If I take out the x squared, we get x squared minus 1. I know, I hate working out integrals. As 1 over x, let's just see, 1 over x to the 5th. This is a side quest from the comments. Oh, it's plus if we make, so we get 1 over x times x to the 4th plus 1 over, oh, this is not fun. Wait. Basically, there are identities for this. Right? The a square plus u square ones. If I made u equal x to the 5 plus 1, du equals 5x to the 4. No, this does not work. Let's see. Okay, this is not working out. We will go back to this and then come back to that later. I hate this. There has to be an easy way to do this. Okay. I really want to do partial fractions, but I don't know if I'll be able to with this. Why does this look like a series? Okay, none of this works. X squared times 1 plus 1 over x squared over I just need to get rid of that. How do I get rid of that? Wait. I get it. This x to the fourth minus x squared times 1 plus 1x squared. This thing, if we take out the x squared, if we take out an x to the fourth, it becomes 1 minus 1 over x squared times 1 plus 1 over x squared. Okay, I thought I was onto something there. But wait, but then that would mean those could cancel out, so let me just write this here. X squared times 1 plus 1 over x squared over wait, I could just take out an x squared. No. I mean, we'll end up with the same thing anyways. I need to just cancel those two out, but I have no idea how to do it. Here, let's go here. Right? Okay, cool. If anyone has any ideas, please say it in the chat. If you like watching me suffer, just say that in the chat too, because I need company. Let me just lower this a bit. Okay. I have an idea. Okay. So, if I'm able to make you... Oh, what calculus are you in, Barrett? This does not feel very basic to me anymore. This becomes... Oh, calculus 2. Isn't that integral calculus? I know calc 1 is just derivatives and stuff like that, limits, right? And then calc 2 would be integrals and series. And calc would be multivariable and gradients, etc. I'm not sure though. Anyways, back to this. Isn't this its own formula? Du du equals 2x, but there are no x's to take out from. Because we could... What I want to try to do is... So if I did this, that would become u minus 1 equals x squared, right? And then u minus 1 squared equals x to the 4th. And then that becomes u over u minus 1 squared minus u du or dx. Now the dx is the problem. If I make this x squared plus 1 over if I make u equal x to the 4th, x to the 3rd, then it could be du equals 3x squared dx. But we'd have to isolate a 3x squared. However, if this du would equal x 4x cubed, and getting an x cubed out of this should be easier, right? See, if I take out my x to the 4th out of this, I get over the problem is there are no x cubes in here. Okay, time to move on to the next problem. See, they could have made life easy and just allowed us to u substitute this, but u substituting would lead to an infinite loop. What if I... So we get 1... Okay, now, so that becomes 1/3 x cubed plus, now time to integrate by parts, 2x ex would mean let's go back to that. Okay, 2x to the ex would mean, let's just solve the integral here. So then you get and then our final one what is e to the 2x? So we could integrate this by parts, which is what I'm going to try to do. What am I doing? Wait, what? Wait, I'm confused. Okay, so if we get e to the 2x, this is equal to ex times ex, which is equal to ex whole squared. Dx of ex squared should equal 2ex. Ah, that becomes that. I see. Chain rule. I hate chain rule. Now, we get that. Okay, yeah, we can work with this. So then we get e equals 2x times x minus the integral of x to right? 2 dx. So that, and then x equals u over 2. So we get e2x times x minus, that basically disappears, the 2 dx, so we get integral of u over 2 e to the u. Du. And this becomes now we integrate this by parts. I'm not. No, but the thing is, there's an... It is? Ah. Wait, are you sure? Wait, but I wasn't sure if you could just substitute it like that. Yeah, I know when it works when you take the derivative, but... Okay. But I just want to solve this out. This looks fun. I'm probably going to get the wrong answer, but... So these cancel out, and we're left with 1/2 e2x. Isn't that fantastic? So if we take everything and put it together, we end up with this took a lot of work. It should have taken much less time. But this entire thing, I kind of didn't know how to take the integral of that. Fantastic. Now let's check if the answer is correct. Okay, it's correct. Now, on to question 5. I don't want to look at question 4 again. Question 3. So, next question. Q5. Let's just write this again here. Question 5. The integral of cosecant cubed x secant x dx. Okay. Now, remember, the derivative of d dx of cosecant equals cosecant negative cosecant cotangent, I think. I'm pretty sure I'm right. Yeah, okay. Now, the derivative of secant, like we found out earlier, equals secant x times tangent x. The integral of cosecant x dx equals negative natural log of cosecant u plus cotangent x and the integral of secant x dx is equal to natural log of secant plus tan. Now, such beautiful formulas. This is also equal to 1 over sine squared now what is sine times cosine equal to? There has to be a formula for this. And there is the double angle formula. Except we're missing a 2. But fear not. The 2 shall come, because if you take u equals sine 2x, derivate this, right? You get this beauty. Oh. This is equal to problem is we don't have that in our original equation. Right now, all we have is 1 over u times 1 over sine x cosine x dx. Which means we need to figure out a way Oh, do you wanna help? I'm stuck, Om. You should help me. Oh. I can do this. Okay. Okay, I'm probably breaking every rule of math here. Right? Then The problem is if we put this in here, we'd essentially be doubling the value. Wait. Okay, wait. So if I plug this in, we get 1 over u times 1 over 2, 1/2 goes out, right? Sine x cosine x squared. Okay. But times, okay, wait, we'll remove this. Right, okay. Then we multiply the entire thing by 2 over 2. That's 1. Since constants go inside, it becomes 1 over u times 2 over 2 sine x cosine x times 2 sine x cosine x, right? This then equals integral of 2 over u times 2 sine 2x squared du. Okay. But we also know that du equals sine 2x. So that means we just got 2 over u times du squared du. Great. And now we have a mess. This is in the denominator. Hi, Barrett. I'm stuck here. If you're able to, like, understand what I have done, and if you could help me, that would be great. Okay. Oh, it's 10:48. Imagine CST. But let's see. How did I even get the DU down there? Okay, wait, I think I got this. So that equals no, I need the plus C. Okay, this took a lot of effort. Let's see. Okay, well, it's wrong. Yeah, the plus C is annoying. It's wrong. We've been able to solve 3 questions in the last almost 2 hours. We just hit the 1 hour and 45-minute mark. We solved the first question with a little bit of help, a lot of help. We were able to easily solve the second question. We easily solved the third question. Fourth question has been a bit of a struggle. No, third question and fifth have been a struggle. We're going to be ending the stream for tonight. We'll pick it up tomorrow. Thank you, the 63 people who watched. Time to go sleep and hopefully be able to do this tomorrow. Bye bye. Thanks for watching, everyone. Thank you to Barrett. He has been here the whole time. Bye.